Good morning students. In last video we have already solved up to question number 3 of exercise 13.3. So today we will solve other questions of this exercise. Now see question number 4. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. Okay, so according to our question here, a well is dug of height or depth of this well is 14 meter. This is 14 meter depth and diameter is 3 meter. This is the diameter is 3 meter. Okay, here we write the height is 14 meter and the diameter is 3 meter. So radius is equal to 3 upon 2 meter. Okay, this is the well. The height or the depth of the well is 14 meter and the diameter is 3 meter. So radius is 3 upon 2 meter. Then again question said the earth taken out from this well has been spread evenly all around it in the shape of a circular. That means here the earth taken out from this well evenly spread out from this. This is the total height of the well, but here the earth taken out from this well evenly spread out the all around the well. Okay, so that means the volume of the earth taken out from this well is equal to the volume of the earth spread all around the well. Okay, and here it is also given that the width of the embankment, this width of the embankment, this is 4 meter. Okay, so now see according to the question, this is the question number 4. The height of or the depth of well, that is H, is equal to 14 meter. The diameter of a well, that is 3 meter. So this implies the radius is equal to 3 upon 2, that is 1.5 meter. Okay. Then what? Now here we find the earth taken out from this well, the volume of the earth. So here you write volume of earth taken out from the well, that is equal to what? This is the well is in the shape of a cylinder. So what is the area? So volume of the cylinder, that is pi r square h. Okay, so that is pi into r is equal to 3 upon 2, that is 1.5. Also here we write also 3 upon 2 square into h is 14. So that is equal to how much? Pi. 3 square is 9, 2 square is 4 into 14. So here 2, here it is 7. That is equal to 9 into 7, 63 upon 2 pi meter. Okay, so the volume of the earth taken out from the well is equal to 63 upon 2 into pi meter cube. Clear? Then here question said what? Now the earth taken out from the well spread all around the well in it form an embankment having height. Here we find the question said you find the height, so let the height be h and the width of the embankment is equal to what? Now 4 meter. Okay, so here we write according to the question earth taken out. According to question earth taken out from the well evenly spread to form an embankment with the width of embankment or with width is earth taken out from the well evenly spread to form an embankment of width 4 meter. So let the height of this embankment is equal to h. Let the height of embankment be h. Okay, so according to our question, the volume of the earth taken out from the well is equal to the volume of the earth used in this embankment. So first you find what is the volume of this embankment. So now let's see, this embankment is like a hollow cylinder. Okay, so first you find the radius of outer radius of embankment and the inner radius is equal to the radius of this well also. So first here you write the outer radius of embankment, that is capital R, is equal to what? Now the radius of the well plus the width of the embankment. So the radius of well plus width of embankment. So that is equal to 1.5 meter plus 4 meter, that is 5.5 meter. This is the outer radius and the inner radius is equal to embankment, that is the radius of a well, that is equal to 1.5 meter. So the volume of earth used to make this embankment or the volume of embankment. So volume of embankment is equal to what? Now this is a hollow cylinder. So that means the outer volume minus the inner volume and both are the cylinder shape. So then it is a pi capital R square h minus pi small r square h. So that is, you can take common pi and h, then it will be r square minus small r square. This is the volume. So now it will be what? Okay, so that is equal to pi into h is equal to h, you can find, and then r square, r is equal to 5.5 square minus 1.5 square. So that is pi into h. Now see, you remember the identities, a square minus b square, that is a plus b whole into a minus b. Otherwise here you also multiply 5.5 in 2 times, then 1.5 and also 2 times, then you subtract. Or to easier, you use the identities a plus b whole into a minus b, that is 5.5 plus 1.5 whole into 5.5 minus 1.5. Then it will be easy. 5.5 into 1.5, that is 7 into 5.5 minus 1.5, that is equal to 4. So then it will be 7 into 4, 28 pi into h meter. Okay, so this is the volume of the embankment, and here 63 upon 2 pi meter cube, this is the volume of the earth taken out from the well. So according to our question, that much earth spread and it make this embankment, that means the volume of this earth is equal to the volume of this embankment. Yes, so now here we write according to question, volume of earth taken out from the well is equal to volume of embankment. So this implies volume of earth taken out, that is 63 upon 2 into pi meter cube is equal to, here it is 28 pi into h meter cube. Pi both side cancel. So this implies h is equal to, h means the height of the embankment. It is not given. So here we have to find the height of this embankment. So h is equal to this, divide this. So that is 63 upon 2 divide 28, that is 63 upon 2 into 1 upon 28. Okay, so then 7, 4, 7, 9. That is equal to 9 upon 2 into 4, 8. That is 1, 8, 1 the 8.10. 10. Then 8, 1 the 8, 2, 0. So 8 2s 16, then 4, 4 0, 85. So 1.125 meter is the height of this embankment. Okay, so I think all of you understood only one thing. The volume of the earth taken out from this well is also equal to the volume of this embankment. Then you compare these two, then you find it. If the radius is already given, so then you can find the height of this embankment. Okay, then come to next question, question number 5. Sorry. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. The ice cream is to be filled into cones of height 12 cm and diameter 6 cm having a hemispherical shape of the top. Find the number of such cones which can be filled with ice cream. That means here a cylindrical shape, a container which is filled with ice cream. A container shaped like a right circular cylinder having diameter 12 cm and height is 15 cm is full of ice cream. So that means here this is a cylindrical container with full of ice cream. The height is equal to how much? I think 15 centimeter. Height is 15 centimeter and the diameter is 12 centimeter. If the diameter is 12 centimeter, this is B is equal to, so R is equal to 12 upon 2, that is 6 centimeter. Okay, and according to our question, this container full of ice cream. Okay. Then again question said what? Now from this container, the ice cream is to be filled into cone of height. Here is a cone of height. This is the height. Cone of height 12 centimeter and diameter is 6. The cone of height, the height of a cone is equal to 12 centimeter and this diameter is 6 centimeter. And having a hemispherical shape of on the top. Here also a hemispherical shape on this top. Okay, that means the ice cream from this container is to be filled of this conical shape, that is here is the cone and one hemispherical top also there. So that means the ice cream in each cone is equal to what? And the volume of the conical shape plus the volume of this hemispherical shape. Okay, then your question said you find how many number of cones which can be filled with this ice cream. Okay, so here we find how many number of cones can be filled from this ice cream container. Okay, so first we find how many ice cream or how much ice creams. Here that means you find the volume of ice cream in this container. So now the container, the cylindrical container of height, or cylindrical container of height 15 centimeter and diameter 12 centimeter is full of ice cream. Okay, so the radius of container, that is equal to 12 upon 2, that is 6 centimeter. So now first of all you find the volume of ice cream in this container, that is equal to what? This is also in the shape of a cylinder, so that is pi r square h. So that is pi into r is 6 square into h is 15 centimeter cube, that is 6 square, that is equal to 36 into 15, that is equal to 540 pi centimeter. Okay, so this is 540 pi centimeter cube is the volume of ice cream in this cylindrical container. Then again this from this container ice cream filled with this conical. So now the volume of, or the first you write here what? Now the ice cream cone is to ice cream is to be filled into the cones of height. So first here you write the height of the cone is equal to 12 centimeter and diameter is 6 centimeter. So according to our question, ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter and having a semi-sphere or having a semi-spherical shape on the top. Having a hemispherical sphere, hemispherical top on the shape on the top. So that means height is 12 centimeter of this cone and the radius of the cone is also equal to the radius of the hemisphere also. So here you write the radius of a cone is equal to radius of a hemisphere, that is equal to 6 upon 2, that is 3 centimeter. So now here we find the volume of each cone or the volume of ice cream in each cone, that is equal to how much? And the volume of a conical shape plus the volume of a hemispherical shape. So here you write what? Now volume of ice cream in each cone means in one cone, each cone is equal to volume of conical shape plus volume of hemispherical shape. Okay, so that means the volume of a cone volume, that is equal to 1 upon 3 pi r square h plus the volume of a hemisphere, that is equal to 2 upon 3 pi r square r cube. Okay, so the hemisphere volume is 2 upon 3 pi r cube, because the total volume of the sphere is 4 upon 3 pi r cube. So the volume of hemisphere is 2 upon 3 pi r cube, and the volume of a cone is 1 upon 3 pi r square h. So now see, 1 upon 3 into pi into r is equal to 3 into 3 into h is 12 plus here 2 upon 3 into pi into r is 3 into 3 into 3. Okay, so now so here also we can write here how much? Now 545 centimeter cube. This is the volume of the container. Okay, so now here you write and that is equal to 3 cancel. Here it is 3 cancel. So that is 12 into 3, that is 36 pi plus 3 into 3, 9 into 2, 18 into pi. Okay, 36 plus 18, that is 54 pi centimeter. This is the volume of ice cream in each cone. So let the number of cones to be filled be n. Let the number of cones be n. Otherwise, here we find, according to our question said find the number of such cones which can be filled with ice cream. Then that means what? Now the total volume of ice cream divided by the volume of ice cream in each cone. So here we write number of cones, such cones which can be filled with ice cream, that is equal to volume of ice cream in container divided by volume of ice cream in each cone. Okay, so that is equal to how much? The total volume of the container is equal to 540 pi centimeter cube divided the volume of the ice cream in each cone, that is 54 pi centimeter cube. Pi cancel, 540 divided by 54, that is. So how many number of cones can be filled with ice cream? That is the 10 number of cones can be filled. Okay. So I think all of you understood. First you find the volume of the ice cream in the container, then you find the volume of the ice cream in each cone, and here it is given cone having on the top a hemispherical shape. So the volume of ice cream in each cone, that is the volume of a conical shape plus the volume of a hemispherical shape. Okay. So I think all of you understood. Clear? Then come to the next question, question number 6. How many silver coins 1.75 centimeter in diameter and of thickness 2 mm must be melted to form a cuboid of dimensions 5.5 centimeter into 10 centimeter into 3.5 centimeter? I think all of you see the coins. So I think all of you knows what type of shapes a coin is. That is the cylindrical shape, because the thickness of the coin is equal to what? Now the thickness of the coin is the height of the cylinder. I think here coin is it. Okay. So see here, this is the coin. So I think all of you see this. Now this thickness is so little thickness is here, but it is also a solid shape. So then here we can say this coin is in which shape? Now this is the cylindrical shape, because this top face and bottom face both are circular face, but the thickness, this is the height of this cylinder. Okay, so a coin is in the shape of a cylinder, and here it is given the diameter is 1.75 centimeter and the thickness is 2 mm. Okay, so now here we write the diameter of each coin, that is equal to 1.75 centimeter. So the radius is equal to 1.75 upon 2 centimeter. Okay, and it is given what? The thickness of the coin is, thickness of a coin is 2 mm. That means first you convert it in centimeter, because both are different units. Always you make all the units are in the same unit. Okay, so if here centimeter, you convert it to 2 mm in centimeter. So then it will be 2 upon 10 centimeter. That is equal to 1 upon 5 centimeter. Okay, this is the thickness. Then what? Now here question said how many number of coins to be melted and then it will form a cuboid whose dimension is also given. So let the number of coins to be melted. So here you write, let the number of coins to be melted to form a cuboid be n. So now you find what? The volume of the coins melted to form the cuboid, that is equal to n. N means number of coins into the volume of each coin. So the total volume of a coin, volume of coins used to make a cuboid, that is equal to n into n means number of coins into volume of each coin. So that is equal to n into volume of each coin. Here we already discussed coin is in the cylindrical shape, that is the volume of a coin cylinder, that is pi r square h. So here we write pi r square h, that is equal to what? Now n into pi into r is equal to how much? Now 1.75 upon 2 square into h is 1 upon 5 because height, thickness, this is the 1 upon 5 centimeter. Now it is n into pi into, here pi is a pi into 1.75, that is equal to, here you remove this decimal point, so then it will be 175 into 2 into 100, then square into 1 upon 5. Now 25 4, 25 7. Okay, so that is equal to n into pi into 7 upon 2 into 4 square, so that is 7 into 7 upon 2 into 4 into 2 into 4, because here it is the square, so you multiply 2 times into 1 upon 5. Okay, so this is the volume of the what? Centimeter. This is the volume of the coins used to make the cuboid. Okay, then according to our question, the dimensions of the cuboid is also given. So here you write the dimensions of a cuboid is a cuboid of dimensions, the cuboid of dimensions 5 centimeter into 10 centimeter into 3.5 centimeter. That means length is 5 centimeter, breadth is 10 centimeter and height is 3.5 centimeter. Okay, so then the volume of a cuboid is equal to, allow to note what, length into breadth into height. So that is 5 centimeter, 5 into 10, I think 5 or 5.5. Here it is 5.5 into 10 into 3.5 centimeter. This is the volume of a cuboid and this is the volume of a coins used to make this a cuboid. So that means according to our question, both the volumes are equal. So now here we write according to the question, according to question, n into pi into 7 into 7 upon 2 into 4 into 2 into 4 into 1 upon 5 is equal to 5.5 into 10 into 3.5. So then this implies n into pi. Pi value here it is already given. This is 22 upon 7 into 7 into 7. Here it is 2 into 4 into 2 into 4 into 1 upon 5 is equal to, here you remove the decimal, 5.5 into 10, this is 55 into, here it is to remove the decimal, so that is 35 upon 10. Okay, now 7 cancel, 2 here 11. Okay, so this implies n into 11 into 7 upon 4 into 2 into 4 into 1 upon 5, that is 5 also, is equal to, here 5, 11, 5, 2. So 11 into 35 upon. Okay, now, but now this implies n is equal to, here according to our question you find the number of coins, that is n is equal to this 11 into 35 upon 2, this divide with this, then it will be reciprocal, so into 4 into 2 into 4 into 5 divided by 11 into 7. 11 cancel, 7 is here, 5, 2 cancel, so that will be 5 into 4 into 4 into 5, 5 into 4 20, 5 into 4 20, 20 into 20, that is 4. So I think all of you understood how many number of coins to be melted to form the cuboid, that is 400 coins. Okay, so that means when we melt 400 coins, then it will make the another form, that is in cuboid form, of dimensions 5.5 centimeter into 10 centimeter into 3. Okay, so I think all of you understood. In next video we will solve other questions of this exercise.